Okay, let's get into scientific notation and let's see how we can multiply and divide and still kind of stay within scientific notation. As we talked about earlier, Avogadro's number is a huge, huge number. We don't want to multiply by that or divide by that. Although we can, it'd be easier actually to do it in scientific notation. So let's take a look at a number here. Let's take a look at some number in scientific notation. Times 10 to the third. Let's multiply it. 3 times 10 to the, I don't know, let's go 4. All right, so if we've got that, and we're going to multiply those guys in scientific notation, I really don't want to make those numbers huge numbers and then put them and multiply them and then put them back into scientific notation when there's actually another way around that. And that's really kind of the same way as multiplying your polynomials. And when we do this, understand that times 10 to the cube and times 10 to the fourth, those numbers are true numbers. So it does play a little bit different, but it's not all that dissimilar from if I said 2 a to the third. So as you can see, I just substituted a in for 10. And if that's the case, then it's the same over here. Because if I substitute a in for that 10, I have to substitute it everywhere. Otherwise, it wouldn't be equal. So now, if I just took a look at this guy, what I'd find out is 2 times 3. I multiply those things that are similar. I get 6. And when I multiply a's, I get a, and I add my exponent, which is 7. So that's what would happen if I would multiply that guy in a polynomial state with letters. So how that works is when I don't have letters, I can multiply it right from here, and I can still get 2 times 3 is 6. Now it's times 10 because it's still that same base, and 3 and 4 is still 7. All right, and I can convert that back to a number in standard form if I'd like. Let's take a look at another one, shall we? Reiterate our point here. Times 10 to the 8th. And of course, after this one, we'll make things a little bit more difficult on you and show you some other problems you may encounter. So I don't want to go back and have to put and substitute a in every single time. So I can just leave it like this. And 2 times 3, as we discussed earlier, I know it's kind of the same problem, it's still 6. We have our scientific notation, so we're multiplying by this base of 10, and we've got multiple bases of 10. So when we do, and we multiply those base 10s, we add our exponents, and 8 plus 3 gets me 11. Very, very simple. Hopefully that reiterates our point from the previous slide. Now, there are going to do a couple other things to us. So let's go 5 times 10 to the fourth. Let's take that times 3 times 10 to the second. Now, what looks very simple, 5 times 3 is 15. Add our bases, so we get 10 to the sixth, is actually that simple. Everything is right except for one malfunction. It's no longer in scientific notation, because in scientific notation it says 1 digit, then a decimal, and then the rest of our numbers, and then times 10 to the whatever exponential value. Well, we don't have that, so we have to make this 1 and 5/10. What that does is that shifts my decimal one place, and we have to, if we have to, we can put it out of scientific notation in a standard form and then bring it back. But realistically, this decimal came from the right. This was a huge number. It just went one more decimal to the right, so I get times 10. And scientific notation, 15 times 10 to the sixth is actually 1 and 5/10 times 10 to the seventh. So be careful of that. If it ends up where you have multiple digits, no decimal, or your decimal doesn't fall 1 digit and then your decimal lands, you have to convert that into scientific notation. Another problem you may encounter. Or situation, not necessarily a problem, is yes, you may have negative exponents. Well, negative exponents aren't any big deal. We still treat everything the same, so let's start this from the beginning. 7 times 3 is 21, and we can already see that we're already out of scientific notation. We'll fix that here in a moment. We are times 10, and 5 plus a negative 4 gets me 1. Well, this number written in scientific notation really doesn't make any sense anymore, but, you know, we are in a learning state. So change this guy into scientific notation. It would take one more decimal shift to the left, okay, which makes it times 10 to the 2. And that is your correct answer, when in fact, it's much easier to go here and just go to standard form. And that answer is 210. All right, so yeah, we took a little bit of a journey there, but at the same time, we do have us in scientific notation, even though the easier method might have been just to simply write out 210. It takes less time, and if we're paraphrasing numbers, it doesn't make sense to paraphrase a number, as I mentioned, in understanding scientific notation, and then write more digits, more operators, more everything. So, but, you know, for educational purposes, there we are. The next thing I'd like to do is we're going to divide. Well, let's go ahead and divide a kind of a simple problem here. Times 10. Let's make that to the 5th. Let's go 4 times 10. Let's make this guy to the 3rd. All right. Well, 8 divided by 4, we already know is 2. But what do we do when we divide our exponents? Well, if you remember back, this is no different than 8 to the 5th over 4a to the 3rd, where we get 2. I have more a's on top by 2, or we find the difference between them and try to make them positive. So there's my answer, as we've already previously learned how to do this. Well, that same method still works over here if I just were to keep it into scientific notation. 8 divided by 4 is still 2. I still have more 10s on top by 2. And yes, your book may ask you to go ahead and change that into standard form. So you take 100 times 2 and get 200. Pretty simple. Let's go on to another problem here. Let's go, let's try this one. 3 times 10 to the 9th over 6 times 10 to the 5th. Well, 3 over 6 is 1/2. So fine. And I know you guys love your decimals, so we'll just leave it as 1/2 or 5/10. And then we have more on top by 4. Well, here again, we're not exactly in scientific notation, so we have to be in scientific notation. Yes, that's kind of our answer, but it's 5, then your decimal, times 10. Well, this number, what it has said is that it had gotten bigger and it moved 4 places from the right. Well, if that's the case, we're moving it 1 back, which means we have to make it 1 backwards. So 5 times 10 to the 3rd. And that's kind of a tricky one. Here again, if you have to see it and you're just not quite understanding what's going on, change that back into standard notation, change it back to a true number, and then move your decimal to where it's 5 decimal and then the rest of it. Last one, because this one's a little bit tricky. Times 10 to the, what do I have here? -1 over 5 times 10 to the 3rd. Well, as we talked about earlier in our exponential rules, that guy goes down. Well, that's fine. So I have 9 5/10 over 5 times 10, and when we put them together, add them, we get to the 4th, which is fine. 9 5/10 divided by 5 is actually 1 9/10. All over 10 to the 4th. Well, really, we want to write that in scientific notation. We have to understand where we're going and why we're going there. So this guy actually goes back to the top, and we get our answer, 1 9/10, which is a scientific notation, times 10 to the -4. Hopefully that helps a little bit when multiplying and dividing in scientific notation.